For over a decade, the architecture of a content delivery network was predictable. You needed as much RAM and SSD storage as possible to keep files close to the user. But Cloudflare's Generation 13 servers signal a fundamental departure from this philosophy. Instead of maximizing local storage for caching, Cloudflare has pivoted toward massive core density. To understand why, we have to look at how the internet has changed. We aren't just moving static images anymore, we are running entire applications at the edge. This shift from storage first to compute first is the defining characteristic of Gen 13. By trading physical disk space for processing power, Cloudflare is optimizing for the era of workers and AI, where the bottleneck isn't how fast you can read from a disk, but how fast you can execute code in memory.
In the early days, a CDN node was essentially a massive hard drive in a rack. The goal was a high cache hit ratio, serving files from local NVMe or SATA drives to avoid the long trip back to the origin server. But today, static assets like images and scripts are only half the story. Modern web traffic is increasingly dynamic. With the rise of Cloudflare workers, the edge node has become a distributed runtime. When a request comes in, the server isn't just fetching a file, it's spinning up an isolate, executing JavaScript, and modifying headers in real time. In this environment, the latency of a SATA SSD, once considered fast, is now a massive bottleneck compared to the nanosecond speeds of CPU execution. This is why Gen 13 removes the massive drive arrays in favor of a lean, compute-optimized footprint.
To power this new vision, Cloudflare selected the AMD EPYC Genoa processors for Gen 13. These chips offer up to 128 cores per socket. But the core count is only half the story. The real secret weapon is the L3 cache. In modern computing, the further data has to travel, the slower the execution. Moving data from an SSD to the CPU takes milliseconds. Moving it from RAM takes nanoseconds. But accessing it from the L3 cache directly on the CPU die takes only a fraction of that. By packing more cores and larger L3 caches into each server, Gen 13 ensures that the instructions for your worker scripts stay as close to the execution engine as possible. This locality of data is what allows Cloudflare to handle millions of requests per second with sub-millisecond cold start times.
To appreciate the Gen 13 trade-off, we must look at the memory hierarchy. At the bottom, we have NVMe SSDs, huge capacity, but relatively high latency. Above that is DDR5 RAM, which is faster but more expensive. At the very top are the CPU caches, L1, L2, and L3. Cloudflare realized that for edge computing, the working set of code, the actual logic being executed, is relatively small. It doesn't need terabytes of disk. It needs to live in the fastest possible memory. By reducing the number of physical drives and reinvesting that power and space budget into higher performance CPUs and more RAM channels, Cloudflare effectively moved the entire operation up the pyramid. This reduces the tail latency, those occasional slow requests that happen when a system has to wait for a physical disk to spin up or a bus to clear.
When we compare the specs side by side, the strategy becomes clear. Gen 12 was a balanced powerhouse capable of storing massive amounts of video and image data. Gen 13, however, is a compute monster. The core count has doubled and the memory bandwidth has increased significantly with the jump to DDR5. Meanwhile, the local storage capacity has actually decreased on a per-core basis. This is a deliberate choice. Cloudflare is betting that the future of the edge isn't just about caching content, but computing it. If you can generate a response or transform a request in microseconds using a worker, you don't need to store a million variations of that response on a local disk.
Beyond raw performance, there is the question of efficiency. More cores per server means Cloudflare can handle more traffic per rack, reducing the physical footprint and power consumption of their data centers. In the Gen 13 architecture, every watt of power is directed toward processing. By using EPYC's high efficiency per watt, they can pack twice the compute power into the same thermal envelope. This allows for a more intelligent edge. Instead of simple routing, these nodes perform complex tasks like WAF filtering, image optimization, and even running small machine learning models, all without the latency penalty of hitting a local disk.
It is a leaner, faster, and more scalable way to build a global network.
The transition to Gen 13 is more than just a hardware refresh. It's a statement about where the web is going. The edge is no longer just a mirror for your origin server. It is the origin. By trading cache for cores, Cloudflare has built a platform optimized for code execution, not just data retrieval. As we move into an era of AI-driven personalization and real-time data processing, the ability to compute at the edge will be the ultimate competitive advantage. Gen 13 isn't just a faster server, it's the foundation for the next generation of the internet. Thanks for watching, and we'll see you in the next deep dive.